Hello, good evening, everyone. Welcome to the second live session for the course Advanced Concrete Technology, which is taken by Professor Manu Santanam. My name is Anupama. I'm a research scholar from IIT Madras. So, without further ado, we'll go to the live session. So, for the newcomers, this is how the course or this live session will be going. I'll be sharing my screen and then I'll show the questions. All the questions are MCQ except one question. So, I'll try to post it in the chat box if the screen is not visible for you, and I'll encourage you to post your answers in the chat box. Some questions we can create it as a poll so that you can express your opinion through the polls. Okay. So I hope things are clear for you. If you have any doubts or any doubt, feel free to unmute and interrupt me in between and ask. Okay. So let me try to share my screen here. Is my screen visible to all? Yeah, ma'am. Is it? Okay, I'm just keeping not in this slide share mode because I just wanted to see your responses as well. Okay, so let me try to keep the screens as such. Yeah, yeah. Okay, I guess this is fine. So, in the week 2 session, what we learned is about different specifications for cement and different classifications, ASTM, BIS, EN classifications for the cement. And we introduced the concept of cement chemistry, what is hydration and what are the different hydration products forming when there is cement hydration happening. So these were the topics which were introduced in the week 2 session. So let's move to the first question. So ASTM standards classify cement into 3, 4, 5, or 6. So you can put the answer in the chat box. Okay, I'll try to put this question same in the chat box. So the question is available in the chat box. ASTM standards classify cement into 3, into 4, 5, or 6. Okay, I can see different answers. Okay, but most of them have commented it is 5. I'm waiting for more people to respond. We have enough number of people attending the class today, so let me wait for some more time. I think this is a very easy question, right? So, can someone put in or comment what are the different types from the ASTM standards? Can someone please unmute? Do you remember which are the 5 types? Okay, I told the answer. So, yeah. So, the answer is C, which is 5. So, ASTM classifies cement into 5 categories. Can someone unmute and tell me what are the 5 categories, please? So, it'll be like a sharing with other fellow classmates also. Or you can feel free to put it in the chat box. Yeah. Type 1 general purpose, man. Yeah. Type 2 is moderately sulfate, yeah, which is actually not in India. Okay. And type 3, the high early strength. Okay. Type 4 is low heat hydration, and type 5 is sulfate resistant. Okay, okay. Also, there are a few countries abroad where they are using type 1 alpha and type 2 alpha, like basically the air intending cements are there. Okay, okay, fine. Thank you. What's your name? Ma'am, Rao, ma'am. Okay, thank you. So we move to the next question. Type 3 cement as per ASTM standards is dash. So, as a person rightly told, there are 5 types. So type 3 cement as per ASTM standards is what type of cement? Option A OPC, option B sulfate resistant, option C rapid hardening, option D is low heat of hydration. Yeah. Rapid hardening is what we call in India. As per their classification, it's high early strength cement. Okay, really nice. I'm getting a few answers here. I'll encourage others who are not have answered till now. Please do answer in the chat box. So that will make the session a bit more interactive. Okay, I can see most of the students have answered correctly. Yeah, I mean, yeah, all of them have answered it correctly. So moving to the correct answer, it is rapid hardening cement, which is also known as high early strength cement. So, since the initial portion of the week was concentrating on the classification, we have a few more questions focusing on that. Okay, yeah. So, the you can see this question in the chat box is what I'm hoping. The type of cement present only in ASTM standards is dash. Option A, moderately sulfate resistant. Option B, low heat cement. Option C, early strength cement. And option D, sulfate resistant cement. Yeah. So these are fairly easy questions for you. I hope you all have watched the videos. Yeah. Okay. Yeah. Let me wait for a few more seconds. Okay, that's it. Does anyone else want to comment? So ASTM for the newly joined attendees, ASTM standards classify the cement into 5 categories, and one of that is only present only in the ASTM standards, not in any other standards. So which is that cement is the question. Option A, moderately sulfate resistant cement. Option B, low heat cement. Option C, early strength cement, and option D, sulfate resistant cement. Okay. Should I wait for some more time? There are 40 plus attendees in the class. I would really suggest you guys to respond in the chat box so that we can make it a bit more interactive. Yeah. So, as all of you rightly told, the correct answer is moderately sulfate resistant cement. Okay. Sorry. Yeah. Moving on to the next question. So, till now we had a very easy, fairly easy questions. So, let's slowly increase the level. Compared to OPC, high early strength cement has option A, lower fineness, option B, high C3S content, option C, high heat of hydration, and option D, less probability for thermal cracking. I would suggest all of you to read the options again carefully. So compare OPC and high early strength cement. Mm, okay. Any more answers, or you want to modify your answers? Option A, lower fineness. Option B, high C3S content. Option C, high heat of hydration. And option D, less probability for thermal cracking. Okay, fine. Does anyone else want to change your answer or, give any new comments to this question? Okay. So when you consider OPC and high early strength, so early strength means that it can mean two things. It can either mean it contains particular cement contains higher C3S, because C3S is the component which is responsible for the high strength or high early strength. So option B is definitely an answer. Now, when there is high C3S content, there will be high heat of hydration, because more hydration will be happening, or the rate of hydration will be much higher. So as a result, heat of hydration will also be much high. So the correct answers are B and C. Okay, so I never told that only one answer is correct. Okay, so that's why just read the options carefully. So the correct answer is B and C. If you see the option A, it is lower fineness, which means that the particle size is bigger, which is a wrong option. Actually, the correct answer is higher fineness. If the fineness is more, then it can give a high early strength. So here the correct answers are B and C. Thanks for those who have responded in the chat box. And whether it is right or wrong, it's not the matter. So now, again comparing to OPC, which of the following statements are true for a type 4 cement? So, first of all, you need to know what is type 4 and comment to the question. So, I have put the question in the chat box. Okay. So, type 4 cement, does it have higher C3S than OPC, lower C3S than OPC, or higher C3A than OPC, or lower C3A than OPC? I can see different answers. I think almost all the options are covered: A, B, C, and D. Yes. So I'm waiting for others also to comment on this question. Whether it goes wrong, it's not an issue. Feel free to comment. Feel free to tell what's your answer in the chat box. I'm waiting for more responses as we have many students who have joined now. So again, the question is, compared to OPC, type 4 cement has higher C3S or lower C3S, or higher C3A or lower C3A, or any more than one option is correct. I don't know. Just whichever you think is the right answer, please put it in the chat box. Okay. Murali Manohar, do you want to share something, or unknowingly you raised your hands? You can unmute yourself anytime. No issues. Okay. Yeah. Yes, Murali. Go on. Hello. Are you there? Murali, can you mute if you're not, if you don't want to share anything? Sorry? Okay. So we move to the correct answer. The correct answer is B and D. So can someone share what is a type 4 cement? So the basic answer is founded on what is type 4 cement. Type 4, okay, I can see one answer. Type 4 is low heat of hydration, therefore, the amount of C3S and C3A has to be low. Uh, okay, as these two are having highest heat of hydration. Yes. So the correct answer is B and D, which is lower C3A and lower C3S. Thank you for responding, Rao sir. So we move to the next question here. State whether true or false. Porcelains require cement in the system for reaction, whereas slag does not. Let me try to put it as a poll question, if that's okay for you guys. Okay, you started answering. Okay, fine. Just go on. Sorry? Chat box, if you're using your laptop, it will be on the bottom line of the Gmeet. So I am getting that the answer is true. That is, porcelains require cement in the system for reaction, whereas slag does not. So, Shravan, can you unmute and speak? Why is it so? Or why does porcelains require cement? Or why slag doesn't require cement? Shravan, are you there? Okay. Okay, I'm seeing Balu sir commented that it's a hydraulic cement, and Pratiksha commented that it needs cement to get activated. Yes, so porcelains basically require cement because it produces calcium hydroxide, and porcelains react with calcium hydroxide in the presence of moisture to form the additional CSH, right? So porcelains definitely require cement. So porcelains like fly ash or calcine clay metakaolin or silica fume, all these require cement in the system. But in the case of slag, it is a latent hydraulic system, which means that it can react even if cement is not present. But if cement is present, it can activate the slag. That's all. So the correct answer is true. Okay. Yeah. Moving on to the next question. It's again a true or false question. Performance based standards do not have compositional restrictions as opposed to prescriptive standards, whether it's a true statement or a false statement. So let me put it in the chat box before you guys start answering. So the question is in the chat box. But read it carefully. Performance based standards do not have compositional restrictions as opposed to prescriptive standards. Okay. Can someone comment what is a performance based standard? Anyone? I'm just waiting for some response from your end. Anyone? Can someone comment what is a performance based standard? Mohit, for the assignments, you can submit it through the portal itself, and the answer will be available after the deadline. So there's particularly no need for sending the answers through your mobile phone. Yeah.
Ma'am, if in a basic term, if you want to say the performance, like we have, say, for self-compacting concrete or the high-strength concrete. So here we are focusing on the performance of the concrete. We are not focusing on the constituents which are there inside the concrete. Like I want these many grams of C3S or these many of C3A or something
Yeah.
like that. We can do modulations into these constituents and get the desired output out of that and make what is the required for the performance, what actually it is going to use in the field.
Perfect, perfect. Thank you, Rao sir. So yeah, basically, yeah, like I can see Balu sir also commented like reactive powder concrete. I think that's what you meant, RPC. Then low heat. That's all depending upon how we want the concrete to be. Whether it require a high early strength, whether it has to be a shrinkage resistant or what else, sulfate resistant, etc. Those are the terminologies which denote the performance of the concrete. So the standards which give focus on the performance are known as performance based standards, and it does not give any restriction on composition. So the correct answer is true. I think all of you got it correct. So it gives us the freedom to uh, use the composition and tweak the composition such that it will benefit for the required performance. So the correct answer is true. Yeah. Moving on to the next question. What does calcination of clay results in? Or why do we calcine the clay? So calcined clay is one of a good porcelain. So the options are it removes the water between the layers and it activates aluminosilicates. It removes the carbon dioxide between the layers. So what does calcination of clay results in? Yeah. So I can see I can see two options. It removes water and it removes CO2. Okay. I'm just waiting a little more time so that others who want to comment can also comment. Please don't restrict yourself from not answering. Feel free to use the chat box or unmute and speak. Or if you want to share anything more from your experience, and feel free to do that as well. Yeah. We have reached 50 attendees. Good. That's all. I'm extremely sorry. There was a network issue from my side. Okay, I lost all the chats also. Okay, fine. So the question was, I hope the screen is visible to you. Is the screen visible to all?
No, ma'am, not yet.
Okay, okay, sorry. I'll share it again. I'm sorry for that. There was a network problem here. Please give me a minute. Now is it visible? I hope it's visible to you.
Yes.
Yeah. So the question was calcination of clay. So what it does is it removes the water between the layers and it activates the aluminosilicates. So clay is basically composed of aluminates and silicates. So what it does, it has a layered structure, and when you calcine the clay, it removes the water between the layers and it activates the aluminosilicates. Okay. So the correct answer is A and B. So this is a fill in the blanks question. There is no option for this. So the fillers and supplementary cementitious materials, that is SCMs, which can be added to OPC at specific dosages, are known as dash as per EN classification. So there's a particular term used in EN classification for the amount of fillers or SCMs which we can add to OPC. Yeah, I guess if yeah, I can see two answers. I think it's, yeah, there's no point in waiting longer, right? So the correct answer is extenders. So extenders are the supplementary cementitious materials or fillers which we can add to OPC for performance improvement as per EN standards. Okay, thank you all for answering to that. Yeah, so the correct answer is extenders. Okay, so moving on to the EN classification. So we know that there's a particular way of naming or terminology for cements in EN classification. So the question is available here. SEM 2A hyphen V 42.5R allows extenders of option A 6% to 20%, option B 5%, option C 21% to 35%, and 36% to 65%. Yeah. Make sure the amount of extenders can be found from the first part, that is SEM 2A. This is also based on the EN classification. I'll give a hint. SEM 1 is the first one, which generally allows the 5% of performance improvement by using extender. Okay, I'm still receiving the answers, so let me wait for a minute more. Okay. Is there any more answers coming? Again, I lost the connection. Yeah, but yeah, chat is available. Okay, fine. Okay. So I got, I think, all the options except D. Okay. So let me try to recall it myself. So SEM 1, it allows extenders up to 5%. SEM 2A, it allows 6% to 20%. So the correct answer is A, option A here. So SEM 2B, it allows from 21 to 35, and SEM 3A allows 36 to 65. Okay, so the correct answer here, since the question is SEM 2A, it is option A, that is 6% to 20%. Okay, okay, so moving on to the next question. Again, the same cement, SEM 2A V 42.5R. What type of extender does it have? SEM2A hyphen V 42.5R has the extender calcareous fly ash, volcanic fly ash, silica fume, or siliceous fly ash. So here, type of extender can be found out from the uh, alphabet after SEM2A or SEM1A or SEM1 or SEM3B. So here that alphabet is V. So V corresponds to a particular extender. So what is that extender? There are different types like quartz, limestone, volcanic ash, fly ash, silica fume. So what exactly is V? Okay, okay. Thank you for answering here. Okay, I can see option B, option C, and option D. Okay, no one vouches for calcareous fly ash. Okay, okay. So clearly, many people, as told in the chat box, V is not volcanic ash. V is siliceous fly ash. I just included volcanic ash just to confuse you. It'll be confusing for me as well. If V comes and volcanic ash is there, I might have a tendency to opt for volcanic ash. But the correct answer is siliceous fly ash. Okay, so the correct answer is D, siliceous fly ash. And congrats to those who got it right, and those who didn't get it right, don't worry. This is just a learning session. Just please remember, you have to remember the alphabets and the corresponding extender it refers to. Okay, so let me go to the next question without further ado. Isothermal calorimeter, sorry, measures dash heat, pressure, temperature, all of the above. So, isothermal calorimeter. The name itself suggests what it is, isothermal. Yeah. Let me wait for some more time. Okay.
Ma'am, this session is till 7 o'clock, ma'am.
It's still 7 o'clock. We'll end it by 7 o'clock. Yeah.
Okay, ma'am. At the last, ma'am, I have one doubt, ma'am. I'll request if you can please clarify that.
Sure. I'll try to wind it up by 6:56 or something. Yeah. Okay. So I guess it's safe to go to the answer. So isothermal means we have a constant temperature. So we are keeping the temperature constant, meaning we cannot measure temperature again. So what we measure is heat from isothermal calorimeter. So the correct answer is A, heat. Okay. Again, we move to the next one. Actual concrete mixes on site or in the site can be tested for heat release using isothermal calorimeter or adiabatic calorimeter. So, which calorimeter we can use to test the concrete mixes? Okay, I'm getting so much adiabatic. Continuously, I'm getting adiabatic. Okay, Maleshwari commented isothermal. Okay, so here I don't think we need to wait. The correct answer is adiabatic because isothermal it is used for checking the heat release of paste alone, not for concrete. Okay, so when we need to check for concrete, we have to go for adiabatic. When it comes to paste, we can use isothermal. Okay, so the correct answer is B, which is adiabatic calorimeter. Okay, next is a question which is related to cement hydration. You all know there is an initial peak of heat when you see the isothermal calorimetry curve or calorimetry curve. So, what does that initial peak refers to, or why is it caused? Is it because of the ettringate formation, or heat of wetting, or monosulfate formation, or initial CSH formation, or more than one option? So, keep this in mind. When a question is shown, it doesn't mean that it has only one answer. It can have more than one answer as well. Okay. So as soon as the water touches the cement grains or the cement particles, there's surface molecule activation happening. Because of that, initial there's a increase in the heat, that is the heat of wetting, which is B. So B is a correct answer. Along with that, as soon as the water touches, there is initially or the early CSH formation happening, which also contributes to the initial heat peak. So the correct answers are B and D. It's not just B, it's B and D. Okay. Thank you all for responding. Again, we move to the next question. Hydration of cement takes place in acidic pore solution, water, or alkaline pore solution, or none of the above. This is an interesting question. I mean, I was watching the video and I also thought that, okay, if I get this question, there's high chance I'll also make this wrong. I mean, answer it wrong. Rao sir, that was a brilliant move. But okay, the correct answer is just C, alkaline pore solution. Because initially, for the hydration to happen, the particles initially dissolve. So the surface alkalis dissolve and the pore solution becomes very alkaline. So the hydration initially itself, the hydration happens in the alkaline pore solution and not on water. Yes, I agree, we do add water, but when we add water, what happens is the alkalis dissolve in that and become the alkaline pore solution. So hydration happens in the alkaline pore solution. We do add water, that I do agree. Okay. So we move to the next question here. Yeah. So the correct answer is C, that is alkaline pore solution. We all have a tendency to answer it as water, but no, the correct answer is C, alkaline pore solution. Okay. Choose the correct statement from the following when the system contains optimum amount of sulfates. So by system, I mean, of course, the cement system, OPC system, or any other system, let it be blended system or OPC system. So, what is the correct statement? Silicate peak follows the aluminate peak, or aluminate peak follows the silicate peak. So, which is the correct statement? Okay, now this is interesting. I'm getting mixed answers A and B. Yeah, I'll wait for a few more seconds. Venkat, you want to comment as A or B? Not A and B cannot be true. It's either A or B. Any more people to comment? Okay, I'm moving to the answer here. So, as you can see here, there's the initial heat burst and the main peak and the secondary peak. So, this is the silicate peak. This is the aluminate peak. So, aluminate peak follows the silicate peak and not the other way around. So, aluminate peak comes after the silicate peak. So, aluminate peak follows the silicate peak. Okay, so the correct answer is B. Now, the primary binding component of cement paste is a very easy question. The primary binding component. Options are CSH, CH, CAH, and ettringite. Calcium silicate hydrate gel, calcium hydroxide or portlandite, calcium aluminate hydrate, and ettringite. So, which just binds the components together? What is a binding component in the cement paste? Yeah, really good. I'm getting a few answers here. A and D. One more way to identify whether it is a multiple correct answer question is here. I am asking the primary binding component of cement paste is, which means it is a singular thing. Binding, I didn't ask the primary binding components of the cement paste are. I didn't ask that. So it cannot be two, it has to be one. Yeah, now you change. Okay, fine. CSH. So, yeah, as many of you rightly told, the correct answer is CSH. Okay, fine. We move to the next question. Hydration of C3S produces dash times portlandite than that produced by the hydration of C2S. Wow, answers are coming very fast. So C3S hydrates, C2S hydrates separately. So whatever the hydration be, the outer products are, or the output is calcium silicate hydrate and CH, calcium hydroxide. So how much calcium hydroxide is produced when C3S hydrates and how much calcium hydroxide is produced when C2S hydrates? So their ratio is what I'm basically asking. Okay, okay, okay. Sorry for that. Okay, the correct answer is D. Anyway, we move to the next question soon. The major raw materials of calcium aluminate cement are bauxite and clay, clay and limestone, limestone and shale, or limestone and bauxite. So here the catch is calcium aluminate. So it has to be something which has calcium and alumina. So bauxite and clay, clay and limestone, limestone and shale, or limestone and bauxite. Yeah, the correct answer is D, that is limestone and bauxite. Okay, because limestone it provides a calcium carbonate, bauxite is a, yeah, the answer is apparently on the screen. I realized it late. So, which is the correct statement again? So, let me put it in the chat box. Conversion of metastable calcium aluminate hydrate phases to the stable phases in high alumina leads to reduction in the strength. That is the first statement. Read it carefully. Second statement is conversion of this metastable to stable phase leads to increase in strength. This is a bit tricky question, so I'll give enough time for that. Okay. Any more people want, anyone wants to answer? Okay. So basically, when calcium aluminate hydrate forms, it initially forms as a metastable phase, say C2AH8 in that form, and with due course of time, it converts into stable phases, which are C3AH6, like hydrogarnet phase. This is accompanied by a introduction of porosity in the system. So, as a result, when the metastable phase to stable phase conversion happens, because of the introduction of new porous media, there will be strength reduction. So, the correct answer is A. Okay. So we have a tendency to think that okay, when the system becomes more stable, there will be an increase in the strength. But no, what happens is when from metastable to stable conversion happens, more porosity is introduced into the system, and as a result, the strength reduces. Okay. We move to the next one. State whether true or false. True solution reaction produces inner CSH. So, true solution reaction produces inner CSH. Okay, I'm getting all the answers as true. Anyone wants to contradict? This is a part of cement hydration. There are two types of reactions happening. One is through solution reaction, the other one is in situ reaction. Yeah, sorry, it's false. Okay. Shrish, since you are the only one who told false, I'm forced to make you answer why is it false. Can you comment or can you unmute? There's nothing wrong if the answer is wrong.
And in true solution, outer CSS forms due to reaction of fine cement particles. And for in we have inner CSS formation. So for that, we have to follow the in situ reaction or with that known as a chemical reaction.
Yeah. Thank you, Shrish. Thanks for unmuting and speaking it. So, and also thanks because since everyone are saying one answer, it requires courage and that much thorough knowledge to say something else as the correct answer. So when everyone told it's true, it's just one person who told it's false. So the correct answer is false because initially when the cement hydration happens, there will be outer CSH formation, that is through solution reaction. There will be a dissolution and then forms the outer CSH. Then the barrier forms, then the water has to penetrate through it and the inner CSH forms as a result of in situ reaction or in the cement grain, that is in situ reaction. So as Shrish rightly told, through solution reaction produces outer CSH, in situ reaction produces inner CSH. Okay, so that's all the questions I have for today. Thank you. So I guess you guys have some doubt. Yeah, Rao sir, you wanted
Yes,
to.
yeah.
Yeah.
Actually, it's a basic doubt, ma'am. Actually, going through the cement since last about 1.5 months studying about only concrete and cement, ma'am.
Okay.
So my doubt is like when sir was telling that the hydration process is an ongoing process. It
Yeah.
never ends, ma'am.
Yeah.
But when we see concrete as a element or a item, ma'am.
Hmm.
So once the curing is the most important part for the hydration part.
Agree. Yeah.
So if there is a wall sort of thing, I just want to know that if there is a wall and the outer surface is being cured,
Hmm.
so that means the outer surface is only receiving the water.
Hmm.
And in the present context, in the present scenario, we talk about non-permeable concrete. We don't want the water to penetrate inside the concrete,
Impermeable concrete. Okay.
impermeable concrete.
Mm-hmm.
So I just want to bring out that the particles which are left unhydrated inside the concrete,
Mm.
how are they receiving this water, man? Because if the outer part of the concrete has got hardened
Mm.
and it has all the hydrated particles done up, ma'am, there is no hydrated particles on the outer surface.
Mm-hmm.
So how does this water reach inside these concrete to those particles which are unhydrated?
See, I'll try to answer. Okay,
I hope you understanding, ma'am.
I
Because
understood. I understood the question.
we
So
are
let
into a concept of internal curing nowadays. We are trying to
yeah.
put concrete curing from inside. But
Hmm.
from outside, once the CSH gel has formed,
Hmm.
then this barrier has gone out and the complete cement particles has got hydrated. That is from the outer part of the concrete.
Hmm.
So if we take a specimen also, like what we do in the lab test maps,
Hmm.
if it is 150 mm by 150 mm,
Hmm.
so the outer part of all the four sides have got completely hydrated and completely the strength has, we got the strength.
Sir Rao, sir, here I would like to comment that it doesn't mean that the inner parts are totally devoid of water. Doesn't mean that. So here Pratiksha has commented curing is to keep up the temperature. That's also correct. And so when we provide water to the outer surface, it is not just for the outer surface. So when there is no water evaporation when there is water evaporation happening from the surface, the inner part most particles or the innermost layer of concrete also needs water. So we provide water from the outside so that it can be taken by the inner particles also and the outer particles also. So I would like to say that the entire system gets cured even if we are providing water only in the outer surface, because no system is there which without any pores or without totally impermeable. Such system is not concrete anyway. It's not such a system. Hello. Hello, am I audible? Hello.